Used to be a fun game when I was a kid playing, try to trace a figure. They're called traversable figures, transversal, travel through them. And they're called networks. And there actually is a way to figure out before you even start. The object is to start at some point and trace the entire figure without lifting up your pencil. Well, let's do the first one. We can start right here, go to here, go to here, and go to here, and that was transversable because I could travel the entire thing. Let's try the next problem. This time we're going to add a little line right there. And let's see if we can transverse this one right here. So we're going to start, let's say, right at this spot right here. So we'll go down and across and up and here, and I did it. Okay? And when we started right here. Let's do the problem again. And this time we're going to start at a different point. We're going to start the point right here. And let's see what happens. We're going to go here, go to here, here, here. Now I'm stuck. I can't go anywhere. Didn't matter where I start, I can't finish this problem if I start at this point right here. So there's a reason why I can do it sometimes and not others. Now let's look at the last problem. Is there a place on this one I could do it? We're going to change it again. We're going to put a line here like before and a line here. Is there any place you can start and do this one? The answer is no, there's not. And it has to do with the vertices and how many segments meet there. So this has A, B, C, D, E. At A, 2 things meet. At B, 2 things meet. At C, 1, 2, 3, 4 things meet. At D, it's 2. And at E, it's 2. These are all even. So it is, no matter where you start, transversable. Now, suppose we look at this one. Where did we start the first time? We started this one. We call it A, B, C, D, and E. Okay? We started here. There's how many at A now? There are 1, 2, 3. And at B, there are 2. At C, there are 4. At D, there are 3. And E, there are 1. Well, now this time we have 2 odd things.